Assalamu alaikum. In this video, let's discuss 2017 question number 36. So here we have an experiment related question. So in an experiment to determine the specific latent heat of fusion of ice using method of mixtures, a student obtained a value which is less than the standard value. So it's less than the standard value. Reasons for lower value of L have been explained by the student. Which of the following statement can be accepted? So that's the question. First, let us understand about the equation related to the experiment. So here, I'm not going to discuss the experiment. Instead, we will come to the equation straightforward. So we know that the heat gained by ice equal the heat lost by water plus heat loss by calorimeter. So you know how to find the mass of water, mass of ice and all in the experimental procedure, but to make things easier, I'll use the mass of ice as Mi. So first, the ice has to dissolve. For that, it will go through the latent heat. So it will absorb the amount of energy equal to latent heat into mass. So that is MIL plus. Next, it reaches a final temperature. It turns into water. So MICW, final temperature, let's say that's theta. So this is the energy or heat gained by ice, which is equal to the heat lost by water. So that is MW CW, initial temperature theta 1. Let's take this as theta final. Okay, theta I minus theta F. So that is the heat lost by water plus, next we have heat lost by calorimeter. So that is going to be M. No, that is going to be, let's say the heat capacity of the calorimeter is given as C. So C into change in temperature, theta initial minus theta final. Now we want to calculate L. So MIL is equal, let's take this common. So MWCW plus C into theta initial minus theta final plus, minus MICW theta final. So now here, let's see what are the factors that is going to change. So first, A. It may have been due to the dew being formed on the outer surface of the calorimeter while doing the experiment. So when dew forms, we know that dew is condensing of water, right? So when water condenses, it releases energy. So that energy is absorbed by water. So it will be dissolving more ice cubes. It will be dissolving more ice cubes. Before that, let's look about this MW, CW plus C. All of them are always constant. mw is the initial amount of water, so cw and c are constant. So in this experiment, the initial amount of water will remain the same throughout the experiment. Therefore, this part is always a constant. Next, how about the initial temperature and the final temperature? Let's think about that a little. Let's say our room temperature is 27 degrees C. Then we will start the experiment around a 5 degrees above room temperature. So we start at 32 degrees Celsius, and then we stop the experiment at 22 degrees Celsius. So doesn't matter if it dissolve more ice or less ice, always I would be starting here and ending the experiment at 22 degrees Celsius. Therefore, this is also a constant. Here, the W and theta final are constants. Then only the mass of ice is going to change. I'll keep the mass of ice on the other side. Okay. So we have Mi L plus Cw theta F is equal to a constant. It is always constant. This amount is constant. Now, here Cw and theta F is constants. Whatever that increases the amount of ice dissolving will decrease the value of L, because if this increase, these two terms together has to decrease, but this term is also a constant. Therefore, the only option is this, to decrease. So in this experiment or in this question, you must check for which reasons will increase the amount of dissolved ice. Okay. Now, statement A. As I mentioned, uh, because of this dew being formed, it will release energy. That energy is absorbed by the ice to dissolve. So, if dew is not formed, it will dissolve a little ice. When dew is formed, that additional energy that will be dissolving a little more ice. Therefore, Mi increase, L decrease. Then A is an acceptable answer. Water on the pieces of ice may have not been properly wiped off before adding to the calorimeter. So, how is this going to affect? Water on pieces of ice may not be properly wiped. So here again, this is going to be constant anyways. I start and end at the same temperature. How about MW? MW is also constant because there is the amount of water before we add. So these are constants. If we do not wipe the water properly, then the amount of ice we have to add increases. The reason is, now let's think this way. Let's say we start the experiment at 32 degrees Celsius and we have to stop the experiment at 22 degrees Celsius. For that, we will need certain amount of ice. We will need certain amount of ice that is at 0 degrees Celsius. So when you dissolve, the temperature goes down. Now you are doing the experiment without properly wiping. So this time you have ice at 0 degree Celsius and water at 0 degree Celsius. So when you dissolve this to change the temperature from 32 to 22, you need a lot of them, because when ice goes from when ice goes or turns into water, it absorbs a lot of energy, but this time there is some water already, therefore you will need more ice. Therefore more ice, L is less. Then statement B is also an acceptable reason. Temperature of ice used may be lower than 0 degree Celsius. So same idea, if the ice used is less than 0 degree Celsius, then we will need less ice, because from lower than 0, let's say minus 10, from minus 10 to 0, it will absorb certain amount of heat. So temperature goes down. Then from 0 to uh, 0 ice to 0 water, it will absorb a little more energy. So the temperature goes down quickly. Therefore, you will need less ice. Then Mi reduces, therefore L increases. So statement C is not correct. Therefore, A and B can be accepted. It has to be the third answer. Assalamu alaikum. Let's meet in another video.